The place to start here is a small rewrite here. You might write this as like 5x to the ninth to the 1/2 power minus
Mm-hmm.
log base 5 of y, like that.
Mm-hmm.
Is that okay so
Yeah.
far? You bring the 1/2 out in front, so it's 1/2 log base 5, 5x to the ninth minus log base 5 of y. And then this inside here splits apart, so it creates more room here. 1/2 log base 5 of 5 plus 1/2 log base 5 x to the ninth minus log base 5 of y. So that 1/2 goes to both. Is that clear?
Mm-hmm.
All right. Now, when these are the same, 5 and 5 is the same, it just becomes 1. So this is just 1/2. This next one, you bring the 9 out in front, so it becomes 9/2 log base 5 of x minus log base 5 of y. So I've seen some of the tests that they give, and they do tend to give you one expand problem and one condense problem on these tests.
Okay.
So I know you can enter this as you go. It's up to you. I mean, I do make mistakes, so it's up to you if you want to enter that or or not.
Okay.
Otherwise, we'll just move on to the next one, which is very similar. You will use this in calculus, so this is an important thing to remember. These
Mm-hmm.
rules come back, and the students like, oh, I didn't learn them, and so. All right, so this becomes log, and it's really base 10. When it's not written, it's base 10. Kind of an interesting thing is they really moved away from logs to natural logs in a lot of textbooks.
Mm-hmm.
But you don't have to write it, but that's what it is. All right, and then we're gonna bring this exponent out in front. So it's 9 log y minus this root is really a 1/2 power. So you can bring that 1/2 out in front log of 3x. And this is the classic exam question here where you have to remember that when you break apart the 3x, that negative 1/2 goes to both.
Okay.
And that's a classic thing that you will see, especially if it's multiple choice. I know your sigils on paper, but um, so that's a 9 there in front.
Okay.
Any questions on that?
Nope, I'm good.
All right, give me just 10 seconds here. We'll move on to another question. All right, so 2 down, 2 to go, and then back into, the trig review. So actually, we should do one more of the expanding ones first. So sometimes I do the problems out of order just to help with the learning. It's good to
Mm-hmm.
kind of do them sequentially here. So what you should see is that this is really x minus 2 over x plus 2 to the 1/2 power. So
Mm-hmm.
that's what comes out in front. One
Okay.
half log base 9 x minus 2 over x plus 2. And then it's an A over B situation, so it becomes 1/2 log base 9 x minus 2 minus 1/2 log base 9 x plus 2. Sum and differences inside the logarithms are nothing you can do with those. This is your final answer on that.
Okay.
Right. So the combining condensing. I guess they call it condensing. I don't know if this is combined. Combined is kind of a better word. Um, what a lot of students remember is that if it's a plus, plus means it goes in the top, minus means it goes in the bottom. A lot of students remember that. However, you're supposed to first deal with the exponent. So it's this, positive natural log a plus b plus natural log a minus b minus natural log of c to the ninth.
Mm-hmm.
And so if it's positive, it goes on the top. So this is natural log out in front. And then it's a plus b on top, a minus b on the bottom. And that's your final answer.
Okay. And so they wouldn't ask you to like simplify that like any further, like do anything
Well,
funky with it.
that's a great question to ask your instructor that's grading it. I'm not grading this, so I don't know. It is difference of squares on the top.
Mm-hmm.
You could argue either one looks better. I mean, sometimes factored form is better than
Mm-hmm. Okay.
right. Have you tried any of these? Do we need to go back and look at it before we proceed to the study guide?
Um, yeah, I've got the web assignment, but yeah, the study guide. We
Okay.
definitely should look back at that again.
And I'm happy to help with WebAssign. I don't know how you feel about some of the online, like Jag and things like that. There's a lot more resources than when I was a student to go out and like find similar problems. Please, it's not a bad thing to go out and look and find all the information you need out there. All right, we left off. I don't know. I think we kind of did like a 9A, maybe. I don't know.
Um, Let me go. Um, where did it go? Oh, there it is. Yeah, yeah, like roughly, yeah.
Do you want us to start? Can I go to 10, or do you have other questions about? You tell me. It doesn't matter to me. They're all kind of the same.
Maybe do 9B because like oh my goodness, like my brain and trying to remember all this is just like
Sure, sure. Yeah, there's a lot here. Some of it useful, some of it not. All right, so there's this substitution. You say let theta equal 2 cotangent inverse x. That's kind of your standard approach here. You let theta or any letter really equal the inside thing because what
oh
that what that does is it makes secant of theta, which is more
mhm.
common. You do divide by 2 in this case. So you have theta over 2 equals cotangent inverse of x. So you do take the cotangent of both sides. And usually the operator's on the left, not the right, but it still is fine. So then you get this x equals cotangent theta over 2, um, which actually is kind of bad. So this is really involved. Which I wasn't expecting. So 1 over x equals tangent of theta over 2 because they're reciprocals.
Mhm.
And then you really need a half angle formula for tangent. So I'm going to look for that because I don't remember it, and I wouldn't expect you to remember it either. Um, boy, so boy, oh boy. This is really going sideways. Normally they don't put a number in front because you can then draw a triangle and you can kind of go about your business with this. But that's not the case here. Like we can't draw the triangle. So um wow. Um
We didn't do a problem like this ever at all in
let me
class,
quickly
so
yeah, let me quickly look at is the answer contained in the at the end there?
no, here, hold on. There's a separate document. Just I need to just get brought up real quick that does. have the answer key. Sometimes the answer key, like on one of them, the answer key was like wrong, and I like had to tell my professor, and she was like, "Oh yeah, it's just an error," and I was like, "Well, it's a pretty big error."
Yeah, they don't care. They're doing a million other things. So yeah, you just have to live with
Yeah.
it. So where we're going with this is that this 1 over x equals plus or minus the square root of, sorry, I'm looking for my reference sheet. 1 minus cosine theta, 1 plus cosine theta. So this is still awful. I mean, this is not typically the direction that these things go. But because you want secant of theta, we might be able to get it out of this. So this is 1 over x squared equals plus or minus 1 minus cosine theta. I'm sorry, that goes away. So plus or minus goes away. Um, yeah, this is really, really awful. You have, is that something you can quickly send over that,
Yeah.
okay.
The answer is kind of strange as well.
That's where we're going. It's pretty dynamic here.
Let me see if
This is where as like someone trying to help you, I would actually say, let's not do this problem with the 2. Let's do it without the 2. And then, um, yeah, or there's another way to do it is to let 2 theta equals 2 cotangent theta. That's another way to do it, which is probably what they meant here. So if you let 2 theta equal 2 cotangent inverse of x, theta equals cotangent inverse of x, you end up getting cotangent of theta equals x. Now you can draw the triangle. That's actually the right approach here. So I made the wrong substitution, but now that we've made the right one, the cotangent of theta is x. So 1 over x and then square root of 1 plus x squared. That's Pythagorean theorem. So now you're looking for now secant of 2 theta, which is really 1 over the cosine of 2 theta. And if you look in your reference sheet, you're going to have 3 flavors of cosine 2 theta. So you pick the one that works best for you to go in the bottom. It depends on the problem, like which one would be best. So since it doesn't matter to me, I'm going to just pick the, I guess I'll pick the, I don't know. They're all horrible. I'll pick the last one. So sine theta is 1 over root 1 plus x squared. So you get 1 over 1 minus 2 times 1 over root 1 plus x squared squared. And then we're making some progress here. And it's more closer to what your answer probably looks like in the book, um, or sheet thing you got. So it's 1 minus 2 over 1 plus x squared with a 1. Then you make a common denominator of 1 plus x squared here. You can hear this isn't very exciting. This is pretty dry, but this is what it appears that they're asking you to do. So then your numerator becomes 1 plus x squared minus 2, which is x squared minus 1 over x squared plus 1. And then you flip and you get x squared plus 1 over x squared minus 1 as your final answer. Which is way out of scope for regular trig class. It's kind of crazy.
yeah.
But having said all that, I mean, the key thing, and that's where I messed up, is I used the wrong substitution. I used a half angle,
Mm-hmm.
which is rarely a good strategy, but I didn't think much about it. The double angle worked out better because the two went away, and then you get the triangle. Your whole goal here is to get the triangle. Once you get the triangle, you can write stuff, cosines and sines of the theta. You still could get it from this other way. I mean, you can see there's an x squared in there. There's like it still would have been doable. It's just that we got going the wrong direction ultimately.
Okay.
Right, so that's B. Do you want it to do 10? 10's more standard, I would say.
Yeah.
Okay. All right, so when you're looking at a problem like 10, if they don't tell you which quadrant you're in, you have to figure that out. Since you're in quadrant 2, you know that the reference triangle looks like that. That's the angle. It's always made with the x-axis. And you got to put the 7 and the 3 and the negative in the appropriate place. It's 7 and 3, TOA, opposite over adjacent, but the 3 is negative. Then you typically almost always find the hypotenuse, a squared plus b squared equals c squared. Square root of 58. And it's always positive, by the way. Radius is always positive because that's what it is. It's a unit circle, radius. It's a physical measurement. It's always positive.
Okay.
All right, now you go to the thing they're asking you to calculate. Like in this problem, it's sine 2 alpha. It could be cosine of 2 alpha. It could be tangent 2 alpha. It could be sine alpha divided by 2, or I mean, really could be anything. Like that's interchangeable. But the formula for sine 2 alpha is 2 sine alpha cosine alpha. So you have to get your sine value, which is 7 over square root of 58, cosine minus 3 over square root of 58. So you get 2 times 7 times 3, negative 42 over 58. And you reduce like that. This is a more standard test type problem you would see.
Wait, sorry. Where did the cosine come from? Sorry, my brain is like.
Yeah, sorry. No, I go way too fast, so please tell me if it's anything is unclear. 'Cause I'm here to help you. I'm not here to. The goal is for you to get that. So in that sheet I sent you, that reference sheet, I can send you a link to it anyway. This is the double angle formula. You have to know this.
Mm-hmm.
I think that's
Oh,
the worst
okay.
part of this problem.
So instead of it just being like theta, it's just replaced with a different
Exactly.
okay.
Exactly. It's called a dummy variable, meaning it's literally anything you want it to be.
Oh, okay.
And
Okay, that
then
makes more sense now. I was like, where did it come from? Like, oh, it's a
right.
train.
Right. And so what you'll find, because you're going to take classes with a whole bunch of different professors from a whole different countries and ways of learning stuff, they're going to do weird stuff. And you're going to be like, you got to raise your hand in class to be like, what do you mean by that? And they're going to realize, oh yeah, like maybe the student doesn't use, you know, Greek letters, or they don't use alphas or betas or whatever. It's okay to ask. It really is. So, but this is a standard test question. This is a good one. It's not overly difficult, requires you to be able to manipulate some things, something like that. All right, I think we did 11A last time, so we can look at
Yeah, we did.
11B.
Mm-hmm.
All right, so there's a few like strategies to tackling these types of problems. You probably only get like one of these on the test, or it'll be a multiple choice thing because these are
Mm-hmm.
hard to grade. Uh, where they ask you like, well, this is equivalent to something else. Here you have to get a common denominator.
Mm-hmm.
So your common denominator is cosine t times 1 minus sine t. All right. So the what you're doing is you're putting with it the one that's lacking. So it's this the one on the right's lacking a cosine t.
Mm-hmm.
And the one on the left is lacking a 1 minus sine t. And this is a pretty standard strategy. So in the top here, it's 1 minus sine t squared. You will FOIL. This one's cosine squared t. All right. Actually, let me actually write it properly like that. Okay. Now resist the urge to like cancel because that's like making 4 right turns. You get back where you started. That's no good. You did this for a reason. Like you got to see it through. So seeing it through is okay. I'm going to write one denominator in the bottom, and then on top I'm going to foil this. What's your comfort level with foiling something like that?
I'd say pretty good.
Okay, could you foil that for us and let me know what you
Mhm.
come up with?
So it'd just be 1 minus 2 sine t plus sine t squared.
Sine squared t. Sine t
But yeah.
squared could be this, which is different. And you probably meant this, but just know that that's how it could be interpreted. All right,
Mhm.
plus cosine squared t. You're as a student, you're supposed to be like, oh, I know what that means, and use this one over and over again in physics, engineering, math. What is sine
Mhm.
squared plus cosine squared?
It equals 1.
Yeah. And there's another one like it's sine squared of like you can just think of like the worst thing in the world, pi e, divided by 10 factorial plus cosine squared pi e divided by 10 factorial. As long as they're the same inside, it goes to 1.
Okay.
It could be 2t, 2t, t squared, it goes to 1. So this becomes 1 minus 2 sine t over wow, this didn't really work out that nicely. Maybe I missed something here. Um, huh. Sorry, I am tired. I don't know if I missed something. This didn't work out very nicely.
Mm.
Do you have the answer to compare to?
Yeah, I have the oh sorry, I just realized I never sent it to you.
That's okay. That's okay. Does it get, I mean, there's not much you can do from here.
Yeah, yeah, the answer was it 11B was 2 secant t.
Okay. Well, what did I miss here? Because I'm missing something. So I can see so sometimes what they give you is the right-hand side. Um, the other way to do this, because sometimes you don't know if you know what you're going towards, that's another way you can do this problem. Um, so like for example here, on the left, it's 1 over cosine t, which is secant t, and then you get the minus sine t over cosine t, which is tangent t.
Hmm.
On the left here, you can multiply by the top and bottom by something different, especially if you know where you're going. If you go by 1 plus sine t and 1 plus sine t, you get um, and then if you distribute on the top, you get cosine t plus sine t cosine t. Oh, and the bottom here, it's 1 minus sine squared t, which is replaced by cosine squared t. So you get cosine t plus sine t cosine t over cosine squared t. So that comes from the sine squared t plus cosine squared t equals 1. Is that clear? 'Cause that's a big one to notice that.
Hmm. Hmm.
And then when you divide each of these, you get cosine t over cosine squared t plus sine t cosine t over cosine squared t. And now you get some cancellations. You get that this one cancels with that one cancels with that one. So you end up getting 1 over cosine t, which is really secant t, and that'll pair with this one, minus tangent t. On the right here, you get a plus tangent t of sine t over cosine t. Those cancel, and you get 2 secant t.
Okay.
It really helps to know where we're going, the direction. Because what we did before wasn't wrong. You could still get there. It's just, it helps to know, okay, it's a secant. That means it's a 1 over cosine.
Hmm.
All right. We should probably do C.
Hmm.
All right. Whenever you see squareds, that should really like resonate with you. Okay, it's Pythagorean identity. There's 3 of them. I'm going to
Hmm.
snip them in. We've talked at length about the one. Um, so this one's the most common, then this one, and so on. Um, the when I see like a 1 minus, I typically think, okay, that's Pythagorean identity, like for sure. So um, and again, kind of like it's helpful to know the answer because there's actually a lot of ways to go here. But if you use the second one, 1 minus secant squared theta, which could be a W, is negative tangent squared theta.
Hmm.
You move the secant left and the tangent right. So you've got tangent squared W minus tangent W over minus tangent squared W. And so you divide them each. That's negative tangent squared W or tangent squared W. That minus on the bottom, make it look correct. And then plus minus tangent W over tangent squared W minus. So on the left, it becomes -1. On the right, it becomes 1 over tangent W, which is cotangent. So if you're asking me, this looks like it becomes like cotangent W minus 1.
Yeah, that appears to be the
Okay.
answer.
Yeah. It's like Google Maps. If you don't know where you're going, it's hard to get directions. It's really important to kind of know where you're going towards. And you might even ask, you might just say, tell the instructor like, hey, this is a proof. What am I supposed to be proving? What is it supposed to get to? Maybe they'll tell you. So like 13 is more of the test question that I was thinking of that you might see. And we don't have to do it, but let me just, they do really like this style of question at the university, um, where like you have to do all the work we just did, and it does reduce to maybe one of these or none. That's awful, but it's like you gotta break it apart.
Hmm.
If you could graph it, like this isn't the right way to do it, but if you could graph this, you might see one of these other graphs. That doesn't help when you've got to show your work. So do you want us to go through this or do you want to?
I think, hold on, let me see. Sorry, I'm doing it real quick.
It's not as bad as it looks. It's yeah, top goes to 1, the bottom's got an identity in it.
Yeah. Oh, okay. Okay, I see it.
Looks like it's B.
Hmm.
Okay. Do you want us to go through 14?
Um,
An even and odd question about cosine and sine.
oh, okay, I see.
Cosine is even, sine is odd.
Oh,
That's
okay. Yeah, sorry, the format of the question. I was like, what am I looking at?
Yeah, it can be very confusing. All right, and then it kind of looks like you're out of trig. Like that's the only the trig that they have here.
Hmm. Yeah, and then just suffer through the rest.
Okay. Why don't you try a problem like number 29, since we did a few of those on the web assign. Let me
Okay.
snip this in. I do like to have this, student you being involved here, if you can. So why don't you try expanding this, ask me some questions if you got any, and we'll see what you come up with.
So for the numerator, because it's to the fifth, like it's square root to the fifth, so it'd be 1/5. And with the y equals 2, would it be like, oh wait, hold up, that needs to, would it be 2/5
Yeah,
log
the
of
reference there, you got it there. Yeah, good.
ny, and then minus log n to the x, base x, and log -9.
These don't split apart because they're if you have a sum or difference inside the top or bottom, it doesn't split apart.
Oh,
Like
okay.
the x minus 9 is like in parentheses.
Oh, okay, I see. Oh, there's the second set of parentheses. Okay.
Yeah. Any questions on that?
Nope, I'm good.
Okay, so 31 is a classic university exam question. They tend to emphasize. I don't have any insider knowledge. It's just from years of seeing stuff. Um, Forget about this. Like, just do exactly what we did in the previous problem for this one. Then we'll deal with this stuff at the end. But just,
Oh, okay.
just do this. Expand that like we did before, and then we'll talk about what to do.
Okay, I think I got it.
Okay. Do you feel comfortable telling me what you got, or do you want me to work it out?
Yeah, so I have so because the square root is only over the 5 and not I put 1/2 log 5, um the 1/2 log base 5, and then plus 3 log 5. Oh wait, hold on, I forgot the a, and then -4 log b.
Base 5 of the, yeah,
Mhm.
you gotta say the base. Okay, good. Yeah, and so what is this first term reduced to when the base is the same as the thing you're taking
Oh,
a log
isn't it
of?
just 1?
Yeah, so with the 1/2 in front, it becomes just 1/2.
Okay.
And then they're telling you, they're making this substitution. Like sometimes it's a number, sometimes they're like, oh, it's 2 or something, but they're telling you it's x. So this part is x. So it becomes plus 3x. This is y. This becomes minus 4y. And there's your answer. 1/2 plus 3x minus 4y.
Okay.
What do you think of that?
I think it seems okay, that's good. Yeah, I'm fine with that.
You've had some other tests. I mean, does that look like something you might see or not?
Yeah, probably.
All right. I haven't seen one in a while, so that's why I'm asking. All right. Get 10, 11 minutes left here. What do you want us to go to next? Like we've kind of checked all the problems like the ones you've done. We've gone through the trig. Do you want us to just go back to like 16, 15?
Oh, I'd say well, let me see if there's any in here. Can't remember if they have. I'd say like writing equations for exponential functions from a graph.
Okay, we'll look at 16 then. We'll do the one on the right first. That's kind of the easier one. Uh there's a lot of like, and this goes to notation, and I do agree it's kind of like first time you see it. So you see actually down below they use this notation. I always like that. It doesn't really matter. Do you have a preference for what you like here?
Mm. The format I think that I'm familiar with is the top one, the top formula.
Okay, we'll use that then. All right. So the you start with usually the nicer one, the one that's closer here. So it's 3 equals k times a to the power of 1. The problem with this is there's two variables in one equation, so that's really bad. Um, so then you try the other one, you're like, all right, it's k times a to the power of 3. So that's slightly better. You've got two equations and two unknowns. This is a little bit of a cheat code here. You can actually just divide these. I like taking the larger one over the smaller. The k's cancel.
Hmm.
6.25 equals a squared. You subtract the exponents. So a is either plus or minus, don't forget that one, square root of 6.25, which is 2.5. Yeah. Now, plus or minus because we don't know, but we have the graph, so we know it's growth. So therefore, it must be the positive one.
Hmm.
Does that make sense?
Yeah.
All right, so you go back to your original equation, you go, okay, it's y equals k times 2.5 to the x, and then you use the nice value. I mean, it doesn't really matter. You can use either, but it's 3 equals k times 2.5 to the power of 1, and you divide, and k is 3 over 2.5, which is like 30 over 25, which is like 6/5, and 1.2. Does that process look familiar to what you saw in class?
Yeah.
Okay. Do you want to try the other one? It's slightly easier.
Yeah.
And um, it is decay, so you're going to have a negative a.
And so for this one, can you still like divide them since
Yes. And
both?
that's always the preference here.
Okay.
You got to be careful though how you do it, right? But the thing
Hmm.
is, with this point though, this one was a little bit different. That's why I said it's a little bit easier because it's to the power of zero. You get carrying
Hmm. Yeah.
because a to the zero is one, so k is four. So then you don't have to divide them like we were talking about,
Oh yeah, that's true.
and that's why it's slightly easier. Um, you know what you come up with for a.
Wouldn't A just equal 4?
So 100 equals 4 times a to the minus 2 power. Did you
Oh,
substitute those values?
sorry, I forgot to plug it back in.
Yeah. You'll find it's I mean it's a number. It's not terrible. Um
Oh, so it would just be like -5.
well here so when I divide by 4, I get 25 equals a to the minus 2. And I would rewrite it like this. You're gonna want to get really comfortable with these exponent rules, especially for calculus. Now you can either cross multiply here or flip both sides. Um, So when you take the square root of both sides, it's plus or minus the square root of 1 over 25 is a, which is plus or minus 1/5. And it's the negative one because it's decay.
Oh, I see. Oh, okay.
Your answer would have been on there as a multiple choice wrong. So here's what you do. Here's what you do to make sure you're right. You rewrite your equation and then you try the points and make sure they work.
Okay.
Um, and I'm saying all that. I know you don't. It's time. You're stressed, all that stuff. But if you can, that's the right way to proceed. Okay, let's talk a little bit about growth and decay factors. So the A is growth, and it becomes 1 plus R, or 1 plus the rate. It's decay, and then it's 1 minus R.
Hmm.
So you have to be really careful that you add or subtract depending on the scenario.
Okay.
And you see that in 19. They're giving you like all the possibilities. Uh, Relative rate. I don't understand C or D, but we'll may not even get there. So for this one, it's the same formula. It's y equals k times a to the x, but a is either 1 plus r or it's 1 minus r, depending on the scenario. So what would the value of a be in this scenario?
It would be positive, so be 1 plus R.
What's the value of r?
0.02.
Okay, I heard the right things there. So k is the initial amount, 23,000, 1.02 to the power of x or t, like that. In part B, it's a decrease. All right, a little slow here. What would the equation look like? Specifically A, what would A be in this new problem?
So A would be so the decimal would be point what's the thing called? 0.005, so it would just be like 0.995.
Yes, very good. I wasn't sure. You were going like and then you got it. It was really good.
Yeah, my brain was like falling asleep there for a
You
second.
did all the right stuff there. Okay. Now I have no idea what the instructor is referring to. People sometimes ask me, "Are you ever stumped by stuff?" I'm like, "No, not really." But like sometimes I have no idea what they're talking about here. Relative rate. It's sort of it's sort of is the tendency is to talk about exponential versus linear. I would maybe ask, or I don't know if you sent that thing over yet. I could look at the solution and tell you what they're trying to accomplish there, but I'm not quite sure.
Was it nine? Oh yeah, 19.
Yeah, 19.
Oh, it's wait, hold up.
I tend to think they're going linear, but I don't know.
Yeah, I think it's like continuous, like the
There we
like
go.
yeah, the continuous rate formula.
Okay, there you go. So that's and that's different. So R in that case, in it when it's growth, it's greater than zero for growth, and R less than zero is decay. And so that, more stuff to memorize and remember.
Hmm.
All right. So we got another session, a few days. It would be good if you were to work through some of these on your own. And that way you're like, hey, Matthew, I did this. I need more problems like this because these are easy for me to make up for you. I'm happy for us to just go through them again. 37 is kind of like there's a lot in 37, so you might want to make sure you take a look at that one, see which ones you know or don't know or want ones more like. There's also extraneous solutions in some of those as well to consider.
Okay.
But I know you got a million things going on. You're a student. But if you have time, that's the best strategy.
Okay.
Okay, we will